Bismillah ar-Rahman ar-Rahim. Now we'll continue 2.4. In this slide, I will deal with questions from the book, and we'll try to solve as much as we can. And for sure, we will solve the suggested problems. In this group of questions, what they are asking about when the function is continuous, or the limit x goes to c from right and from left, and x goes to c. So we can discuss the continuity of the function. And I'll do this, just the continuity from the function. At this one, limit as goes to c in this one from right or from left is the same, which is 3. So the limit exists, and the limit equal to f at 4. So it's continuous everywhere. We're not talking about any point C, where C is this point, the point chosen. So the same thing here, right equal left, the same, and everything equal to -2, so it's continuous everywhere. Here, I have problem of continuity at this. Why? Since the limit from right, limit from left exists, but not equal f at 3. So x equal 3, we have discontinuity. The same thing here, right equal left, but not equal to f at -3. So we have at x equal -3, discontinuity. Here, light not equal to left, so the limit does not exist at x equal 2. So we have a discontinuity here at c equal 2 or x equal 2. Okay. This is at c equal -1, right not equal left. So we have a discontinuity at x equal -1. Now let me move to the questions in this one, which is mainly about limit from right and left. Mainly is about limit from right and left. Okay, let me do some of them. 14, limit x goes to 4 from right of this one. If we substitute, you are getting 0/0. It means you need to do something, which is very clear. I will factor this x -4 times x + 4. Well, this is equal -1. So substitute, you get -1/8. 15, limit as it goes to -3 from left, x over square root x squared -9. Yeah, this will be non-zero over 0. This will be non-zero. This is, if we substitute, to get non-zero over 0. So I'm going to plus or minus infinity. This is 0, and this is for sure positive. This is negative, so I'm going to minus infinity. 16, limit as goes to 4 from left, square root x -2 over x -4. If we substitute, we are getting 0/0. That means we need to rationalize in this case to rewrite the function a different way. So that will be limit x to the power minus, this is x -4 over x -4, square root of x + 2, cancelled. Substitute the 4, it will be 1/4. Yeah, such problem, actually, there is no difference between going from right or left or at the point. 18, limit x goes to 10 from right, absolute value x -10 over x -10. This now will make a difference. It goes to 0 from 10 from right, that will be positive. I get rid of the absolute value. This is my first step. That will be positive, so it will go out as is. So the answer very clearly, it's equal to 1. 19, limit as delta x goes to 0, 1 over x plus delta x minus 1 over x over delta x. Substitute, you get 0/0. That means I need to remanipulate the function in a different way. That will be what? X minus delta X over X plus delta X times delta X cancelled. Also the X cancelled with delta X. I'm getting what? As X goes to 0, this will be 0. So I'm having minus 1 over X squared, which is actually the derivative of 1 over X. Now 21, limit is goes to 3 from left of this function, where f of X is what? It's this function, X plus 2 over X. If X is less than 3, 12 minus 2X over 3, if X greater than 3. So when you talk about limit X goes to 3 from left, that means what? I am where I am in this side, so I will use this function. So it will be limit X goes to 3 from left of this function, where if I substitute, I'm getting a value. So we can just substitute 3 plus 2, which is 5 over 3. 22. What is the limit as X goes to pi of cotan X? Be careful here. That will be what? Yeah. Cotan is what? Cotan is cosine X over sine X. Okay. So we have non-zero over 0. So it's like an infinity category. That will lead us to what? From left, this is cosine. This is cosine X. So this is pi. I mean, this is pi and this is minus 1. So if it goes to pi from right or left, this is always negative. And this will be 0. But as for cosine, for sine, this goes to 0 from, no, sine is this one. This is pi. Okay. So if I take it from right, limit goes to pi from right of this one, it will be what? It will be here. It's an infinity category because it will be non-zero over 0 in both cases. But this will be negative, and this one will be pi plus will be negative 2. So this is plus infinity. However, if I deal with this goes to pi from left on the same function, that will be still non-negative, but this one pi from left, which is here, so that will be plus infinity, minus infinity is the answer. So that means the limit as it goes to pi of cotan X does not exist. And it's not infinite or not, it does not exist. This is 22, 25. Limit as it goes to 4 from left, 5 greatest integer of X minus 7. What I need to do, I need to check this for the greatest integer of X. X goes to 4 from left, which is like 3.99. If I put it there, I'm getting what? 3 minus 7, so it's 15 minus 7, which is 8. This is 25. 28. Limit as it goes to 1, greatest integer minus X over 2. My concern is about this one, for the greatest integer. We agreed if we have non-integer, no need to check left or right. You just substitute and that's it. So that will be 1 minus greatest integer of minus half. Greatest integer of minus half is what? Minus 0.00, minus 0.5. It will be minus 1. So the answer is 2. 29. Limit as it goes to 3 from right, of len x minus 3. We know that this is the len x minus 3. This is the len. I can graph actually len x minus 3 where I have a 3, and this is the function. It's the same as len x, but with the shift. So as 3 from right, I'm going to where? To minus infinity. This is 29, 30. Limit as it goes to 6 from left, then 6 minus x. Either you graph this one, which is, if this is len x, so len of minus x, len of minus x, it will be like this. This is len of minus x with just a reflection about the y-axis. And len of 6 minus x, it will be this shift. Now 6 from left, I'm going to where? To the same thing, minus infinity. Okay. 31. Limit is goes to 2 from left of len x squared 3 minus x. What we care about is this one should be 0 from right, and it is. If you put the 2, no, it's this actually it will be a number, huh? Is it? Just let me double check it. This is what? 31. Where is 31? It goes to 2 from left with just substitution. Nothing is there. Okay. I was thinking it's more complicated, but it's okay. No need. Just substitute. You will have what? Len of 4 times 1, which is len 4. That's it. Nothing to worry about. There is nothing to worry about. 32. Limit as goes to 5 from right. X will goes x minus 4. If I substitute and get what? 5 over 1, which is 5. No need to worry about it. Now, 35 and 36, they are from the graph. So they are discussing the continuity. Here we just check right and left. We just discuss the continuity. For sure, I have this continuity here, and I have this continuity here. So I have at x equal 2 and x equal minus 2. I have this continuity. And this one, I have this continuity here. Clear, at x equal minus 1. From the graph, and this one, I have continuity at each integer, at all integers. Okay, because it will make a problem here. Well, at each integer, there is a jump. There is, a jump. Here I have this continuity at x equal 1. We have a discontinuity at x equal 1. Okay. Let me continue doing these problems. 38. This is the graphs. Huh? 38, they want what? This is 38. 38, 37 to 40. They want to discuss continuity in the closed interval. But as we agreed to discuss the continuity in the closed interval, I need to check the inside interval, and then I check the one for minus 3 from right and the 3 from left, the continuity things. So I will do 38 and 39. We'll do it here. I think I have a space here, so we can do it here. So 38, my function is what? 3 minus 9 minus x squared. And the interval minus 3 to 3. So first, I will check the open interval where everything is defined, nothing to worry about. So the limit takes c, and this minus 3 and 3, any value c. So the limit is goes to c of this We'll be just substituting 3 minus 9 minus c squared, since everything is defined, nothing to worry about, which is equal f of c. Now for x equal minus 3, I need to check the limit as it goes to minus 3 from right. Minus 3, yeah, this is the interval. This is minus 3, and this is 3. So I need to check the point here, which is right of minus 3 is equal f of minus 3, which is the case. If minus 3 from right, you just substitute since everything is defined. It will be 3 minus square root 9 minus 9, which is 3. And the same thing here. 3 minus square root 9 minus 9, which is 3. So they are the same, so it's correct. And the same thing for x equals 3. You can check it, where you check any limit x goes to 3 from left and this side equal f of 3, which is 2. Just substitute. So the function is continuous in this interval. Next one, 39, is what? This is the function 3 minus x and 3 plus half x, where x is less than or equal to 0 and x greater than 0. This is a little bit different. This function is continuous everywhere. This function is continuous everywhere. They are polynomials. So I need to worry only about the 0. So for 0, I need to prove this. Limit as it goes to 0 from right equal limit as it goes to 0 from left equal f at 0, which is the case. From right, I am here, that will be 3. From left, I am here, that will be 3. F of 0 is there, so it will be 3. So the function is continuous everywhere. Okay, let me go back to the problems. This group of problems, what they want, from 40 to 60, they want find the x values for which the function is not continuous and check is it removable or non-removable. So the discontinuity point and they are removable or non-removable. Let me do it here. I'll do what is that? 41 f of x 4 over x minus 6. For sure, I have discontinuity at x equals 6. But the function is not defined. Actually, we're looking at what the function is not defined. So if we check the limit, what control is it removable or not? If the limit exists or limit does not exist. As this goes to 6, we do it from right. I'm getting what? I'm getting infinity. So it's positive or plus infinity. And from left, no need to check class. So the limit, so it will be not removable, but for completeness, 6 from left, that will be what? Minus infinity. So the limit as goes to 6 does not exist. So we have non-removable continuity. Actually, we get it from here. Non-removable discontinuity. It will be an infinite discontinuity. Okay. 1242, I mean, which is this function. The function is continuous everywhere. Because this thing is x squared plus 1, impossible to be 0. 44 f of x equal what? Sin x minus 8x, is it? What is this? Yeah. Sin x minus 8x. Sin x minus 8x, which is the domain, it's all everywhere, so continuous everywhere. 44, 46, f of x will be x over x squared minus 4, where the function discontinuous if x squared minus 4 equals 0, it means x equal 2 or x equal minus 2. If you take the limit, this goes to minus 2, for example, from right, since I'm going to plus or minus infinity. So the limit will not be exist, does not exist. Minus 2 from right, so this is positive, this is negative, this is positive, I'm going minus infinity. So we have non-removable discontinuity. Non-removable discontinuity at x equal minus 2. 2, do the same, which is, I think, it will be plus infinity. So the same thing, non-removable. At x equal 2. 48. Where is it? 48. Yeah, f of x will be equal x plus 2 over x squared minus x minus 6. I have discontinuity if x squared minus x minus 6, which is x minus 3 times x plus 2 equal to 0. So x equal 3 or x equal minus 2. So check the limits as this goes to 3 from right. I'm getting and cancel since x not equal to minus 2. So this is will be what? This is positive plus infinity. So we have non-removable discontinuity. If x equal to 3. However, if I check for the limit, x goes to minus 2, the same one. I know it's wrong. X plus 2 cancelled. Since x is not equal to minus 2, I'm getting what? 1 over minus 5. Here we have for sure limit exists, so we have removable discontinuity at x equal minus 2. Okay. I think it's a good question explaining removable and non-removable. We'll do 50. And the function is 2 absolute value x minus 3 over x minus 3. Well, this is discontinuous if x equal to 3. Check the limit. As goes to 3. Since it's an absolute value, 0, so I need to do it from right and left. That will be positive, so I'm getting 2. That will be negative, so I'm getting minus x minus 3, so I'm getting minus 2. So I have non-removable discontinuity. But x equals 3. And the limit does not exist. We have jump, actually, jump discontinuity. 52. F of x equal minus 2x if x is less than or equal to 2. X squared minus 4x plus 1 if x greater than 2. Here everything is continuous, just we need to care about 2. So check the limit as goes to 2 from right of minus 2x, that is minus 4. Limit as goes to 2 from left, that will be what? 4, 5 minus 8 minus 3. They are not equal to each other. So we have non-removable discontinuity. We agree we have removable if the limit exists. And it will be continuous if it's equal f at 2. But this is, we have no removal of continuity at x equal to 52. 53. F of x is what? Tan by x over 4 and x okay. First I need to deal with these things. What's the meaning of that? That means x between -1 and 1. And this one means what? X less than -1 or x greater than 1. So I will rewrite the function f of x as what? As tan by x over 4 if x greater than 1 and no, it is x if x is less than -1. We have the equality here, so this is equality, and tan by x over 4 if x is between -1 and 1 minus x, x, I mean x, it's the same x if x greater than or equal to 1. So this is the function. This function is continuous. Tan has a problem, but in this interval between -1 and 1, it means this is between minus pi over 4, pi over 4, which is okay. Tan is defined, everything is okay. And this one is continuous, always everywhere. So I need to check only these junction points at x equal -1. Check the limit as goes to what? To -1 from right. From right, so I am here, tan by x over 4. That will be what? Minus pi over 4, which is -1. And from left, I am there. That will be x, so it will be -1, so they are equal. It means f is continuous. Oh, what about? I need to check f at -1, which is here, which is -1. So f is continuous, fx equal -1. Now for x equal 1, I'll do the same. Limit x goes to 1 from right. So I am here. That will be x, which is 1. Limit is goes to 1 from left. So that means I am there. That will be tan by x over 4, which is, if you substitute, you have pi over 4, which is 1. And if at 1, which is 1, 2. So if it's continuous, if x equal 1. So the function is continuous everywhere. If continuous everywhere. This is 53. 54. F of x. I think that there's a mistake. Cosecant by x over 6. Well, I have absolute value x minus 3 less than or equal to 2. And 2, f absolute value of x minus 3 greater than 2. No, maybe there's no mistake. The same idea, I will deal with this one. I make it x minus 3 between -2 and 2. So x between what? 1 and 5. No, there's no 6. If we substitute, you have what? Pi over 6 and 5 pi over 6, which is first and second quadrant, so everything is defined. You have no problems. Nothing will go to 0. So it's defined. Here we have x minus 3 less than -2, or x minus 3 greater than 2, which is what? X less than 1 and x greater than 5. So my function is is what? Is 2 fx less than 1 and cosecant by x over 6 fx between 1 and 5 and 2 fx greater than 5. Okay. Those functions are correct. This function is correct. Function correct. Everything is correct. Everything is continuous. You have no problem there. So now we need to check only these junction points. From left is 2. From right, it's cosecant pi over 6, which is 2 also. This is 5 pi over 6, which is 2. So at x equal 1, limit is goes to 1 from right. From right, so I have cosecant by x over 6, which is cosecant pi over 6, which is 2, which is the same as the limit as it goes to 1 from left of the function, which is 2. And from left, it will be 2. To make it clear, f of x. Now, when you deal for the function from the right, that will be cosecant by x over 6. So this is 2. Limit is equal 1 from left. So I will deal with 2, which is 2. F of 1 is 2. The same thing for x equal 5. That will be cosecant 5 pi over 6, which is 2. And this is 2. F of 5 is also 2. So this is also continuous. So the function continuous everywhere. I think it's clear. No need to rewrite it. It's similar to that, to the previous one. 55. We have the function, which is ln x plus 1. If x greater than or equal to 0, 1 minus x squared if x is negative. This is continuous, it's defined everywhere since this is greater than or equal to 0, so the argument is always non-negative, or always positive, I mean. And this is the continuous function. Just need at the 0, limit x goes to 0 from right. I'll take this. That will be ln 1, which is 0. Limit x goes to 0 from left. I have 1 minus x squared, and that is 1. So we have non-removable discontinuity at x equals 0. At x equals 0, yes. 56. That's the same idea. Just I will put the answer. That will be 10 minus 3 e5 minus x, if x greater than 5. And this is 10 minus 3 over 5x, if x is less than or equal to 5. This function is continuous. This function is continuous. No need to worry about it. Just worry about x equal 5. Where limit from right, it will be what? 10 minus 3, which is 7. And this is the limit from left. It will be 10 minus 3, which is 7. Huh? So you can write it as it's right from right. I am here. So with the function, that will be what? 10 minus 3, which is 7. This goes to 5 from left. With the functions, that will be 10. With the 5, 10 minus 3, which is 7. So it's continuous everywhere. Continuous everywhere. Like the one above it, 55. 57. This is the function cosecant 2x. We want to check, is it? We did all of these, we reached these things. Huh? We reached this group. We did all of these ones. Okay. Okay. So I have to check when this function is not continuous. If you notice, this function is what? 1 over sine 2x. So I need to avoid the sine 2x equals 0. Should not be equal to 0. So we have what? When sine 2x equals 0, that means if 2x equal n pi, not equal n pi, since I'm saying not equal, So x not equal to n over 2 pi. So the function is continuous, discontinuous if x equal n over 2 pi. And at that point, you have removable or non-removable. If you substitute, you will have sign in pi, which is 0. So you have non-zero over 0. So we have non-removable discontinuity. Actually, I have an infinite one, non-removable discontinuity, because it will go either to infinity or minus infinity. It depends from right or left. I take 58, which is similar a little bit, f of x equal tan by x over 2, which is what? Sine by x over 2 over cosine by x over 2. I need to avoid this not equal to 0. And that's true if by x over 2, I know when cosine is equal to 0 at pi over 2 plus n pi. So this is not equal pi over 2 plus n pi, because it will be pi over 2, 3 pi over 2, 5 pi over 2, and so on, which is the odd ones. Now multiply by 2 over pi, multiply by 2 over pi, you have what? X not equal to what? 1 plus 2n, 1 plus 2n. So if x is an odd number, for sure we'll have a discontinuity. So the function is discontinuous if x equal 1 plus 2n. 1 plus 2n. But it's very clear if I substitute, for example, take 3. Cosine 3 pi over 2 is what? 3 pi over cosine 3 pi. Take n equal 1, for example. Odd numbers. This is represent the odd numbers. Huh? If n equals 0, then x equal 1. If n equal 1, it's 3. This is the odd numbers. Huh? Odd integers. So you have to check, is it removable or not removable? Substitute here, you will get 0. But substitute here, it will be what? 1. So I have non-zero over 0, for sure I have non-removable discontinuity. I don't have removable, since it will go either to infinity or plus infinity or minus infinity. It depends from right or left. The last one in this group, 59, I have f of x equal great integer x minus 8. Yeah, that's the last one. This one is the same idea. So this is when it's discontinuous. It's discontinuous if this is an integer. And that's true if x is an integer. The function is discontinuous. And we know that at that time, if we take any integer, we know that the limit right does not equal limit left. So we have non-removable discontinuity. If x is an integer. And the same thing for the other question, which is 60. Same idea. Okay. Now we need to do more problems. This is, let's say what? An exercise is find the constant A. He put the constant A somewhere here, there, something like this. Find the constant A so that the function is continuous everywhere in the entire number line. So he wants you to find A so that the function is continuous. I'll do some of them, 2 or 3 of them. I can continue here. 63. The function is what? G of x equal x squared minus a square over x minus a, where x not equal to a, 8 if x equal to a. I want this to be continuous everywhere. For sure, this is continuous since x not equal to a, and this is continuous. So my concern only is about a. So I want the limit as goes to a from right equal the limit as goes to a from left equals f of a. Limit from right or from left, I can do the limit for this one. Let me do it here, which is the easy one. That will be limit x goes to a, x minus a of x plus a over x minus a, cancelled. We don't care plus or minus. This will be 2a. So this is 2a, this is 2a, and f of a is equal to 8. So a should be what? 4. So a should be 4 in this function. 64 f of g of x is 4 sine x over x, and this is a minus 2x, where x is negative and x is positive. So this is continuous, nothing, because we worry about 0 where it's not in this interval. There is where is the equality? Equality with this. This is the equality. Okay. So I want the limit as this goes to 0 from right equal the limit as goes to 0 from left equal f at 0. This will be different than this one. This one I have right and left the same, since I have x not equal to a. Here, left and right will be different. Right, I am here, so that will be a minus 0, which is a. X goes to 0 from left, I have this limit. By the way, f of 0 is a. No need to worry about it. 4 sine x over x, which is special limit. I know this is 4 and this limit is 1, so it's 4, so a equal 4. This is what I want. Nice. All the questions, the answer is 4. Okay, 64. I have f of x equal what? 2e ax minus 2, if x is unequal to 4, and I have ln x minus 3 plus x squared if x greater than 4. If x greater than 4, this is defined. We have nothing to worry about it. Also, this function is always continuous and defined. So we are concerned only about 4. So you have limit x goes to 4 from right equal limit x goes to 4 from left equal f of 4, which is the same here. So I don't need to worry about it. 4 from right, I'm here, substitute, you have ln 1 plus 16, which is 16. This one will be what? 4 from left, it will be 2e 4x minus 2. Am I right? Yeah, I just put x equal 4. I need to solve this equation, take 2 to the other side, so I have 18 equal 2e 4x. Left. Yeah, just substitute x equal 4. So that means 9 equal e 4x. Take ln of both sides. I have ln 9 equal 4x. So x will be equal what? 1 over 4 ln 9. So this is the point, or a, huh? For a. For a, this is a. So this is my a. Okay, that will be 64, or 64, yeah. Yes. I did all of this. No, 65. Yeah, that was 65, not 64. This is 64. This is 65. Which is this one? Actually, 66, not 65, not 64. 66. 65, the remaining one, I think you can do. Just the same idea. Substitute, you get the A, which is A plus 3 should be equal to arctan of 0, 0 equal to 2. So A equal -1. This is 465. We solve them all. Now, this is continuity for the composite function, which is we know if the function is continuous, if the function f is continuous, and this is continuous, so the composite is also continuous. So no need to worry about this. Finding discontinuity, I have to check discontinuity for these functions when they are discontinuous. Exercise is a graphic utility, and we'll try to do it analytically. Use the graph to determine an x value for which the function is not continuous. Okay. Let us do 71, which is the integer of x minus x. Yeah. When this function is discontinuous. Yeah, discontinuity comes from here. Well, left not equal to right. So this function is discontinuous if x is an integer. Yeah, that's all. I choose only one. Yeah, the rest, just you can check. This one very clear. The denominator not equal to 0. This you need to check this and this. These endpoints, are they the same or not? So I leave it for you. Now we'll do 75, where I need to describe the interval which the function is discontinuous. Okay, here you want me to do it through the graphs. Here I'll do it in calculations. So actually this one it needs the graphic utility, but this one I think we can do. So I'm doing it. Also the rest, all of these we can do. But the same idea will be here. But this is I choose it since it has the greatest integer function. Okay. Now we'll go to 75. F of x equal x over x squared plus x plus 2. I will check when the function is discontinuous. So you have x plus 2, x plus 1. Very clear. The function is discontinuous. If x equal -2 or x equal -1. Okay. 76. F of x plus 1 over the square root of x. Actually, we're looking for the domain. So what is the domain here? I need this to be positive. X is greater than 0. That's it. So the function is continuous if x is greater than 0. Okay, same thing. I need the domain here. Say it's continuous r minus -1 and -2. -1, -1, -1, -1. So it's the same. 78. F of x equal x square root x plus 3. So for sure need this to be positive, greater than or equal to 0. Here I don't need the 0. So it means x greater than or equal to -3. Just I need the domain. I'm looking for the domain. 79 secant by x over 4. Qualitative of x secant by x over 4, which is what? Which is 1 over cosine by x over 4. So I need to avoid cosine by x over 4 not equal to 0. And that will happen if by x over 4 equal pi over 2 plus n pi. Multiply by 4 over pi, not equal. Multiply by 4 over pi, you get what? X will be equal what? 2 plus 4n. So x not equal to 2 plus 4n. So it will be all real numbers where n is integer, where n integer. So it will be all real numbers except 2 plus 4n, where n is an integer. Okay. 80. F of x equal cosine 1 over x. For sure, I have the domain x not equal to 0. So all real numbers except 0. 81, is it? When we are done. Yeah, 81, just piecewise function, who cares? 81 is what? F of x equal x squared minus 1 over x minus 1, where x not equal to 1, 2, if x equal 1. So this function is continuous since x not equal to 1, continuous. So I need to check at 1, limit as goes to 1 of this. That will be what? Limit as goes to 1, x minus 1, x plus 1 over x minus 1, cancel, that will be 2, which is the same as f at 1. So the function is continuous everywhere. Okay. Now this group of functions is asking about what? Explain why the function has at least 1 0 in the given interval, which is what we are talking about is the intermediate value theorem. We're talking about intermediate value theorem. So let me do 84. So we're talking about intermediate value theorem. 84, which is f of x cubed plus 5x minus 3. And the interval given is 0 to 1. So the function is continuous in this closed interval. Actually, it's continuous everywhere, but we are concerned about this. And if at 0 will be minus 3, negative. And if at 1, it will be 1 plus 5, 6 minus 3, 3, positive. So for sure, intermediate value theorem shows there is at least 1 0 C belongs to the interval 0 and 1 such that f of c equals 0. Yeah, that's good. I'll do 89. 89, what he want? Explain why the function has at least 2 zeros in this given interval, 1 and 5. Let me check. 89. What is the function? The function is x minus 3 squared minus 2 plus 2. Minus 2. Minus 2. We know how to graph this function. This function is parabola 3 and minus 2. And at 0, it will be what? At 0, it will be, yeah. And just I want to graph it. At x equals 0, it will be 9 minus 2, 7. This is what? X equals 0. Means y will be 7. So 7 somewhere here. Y. Oops. Let's do something like this. Okay. And the interval given is 1 to 5. For sure they'll be here and here. This is what I want to do. And this is 3. This is 3. You want us to show that there exist 2 zeros, which is very clear. I have the interval 1 to 5. 1 to 5. Now, if I choose the interval, if I split the interval into 2 intervals, 1 to 3 and 3 to 5. The function is continuous everywhere. 1 to 3 and 3 to 5. So I will do it. I will do the intermediate value theorem for these two different intervals. So we have f of 1 will be what? 1 minus 3, which is minus 2 squared, 4 minus 2, which is positive. F of 3 will be minus 2, which is negative. So this will give me there exists intermediate value theorem. There is this 1, 0, at least 1, 0 of f 1, 0 c in the interval 1 to 3. And the same thing if I'm doing it for 3 and 5, I know this is negative. So f of 5 will be what? 5 minus 3, 4 minus 2, positive. So these two would give me by intermediate value theorem at least 1, 0 of f, where that 0 belongs to 3 and 5. So how many zeros we have? For sure we have 2 zeros, because 1 between 3 and 5 and 1 between 1 and 3. So we have 2 zeros in this case. Okay, this is 89. So we did this group of questions. Now, what is the remaining? This group of questions, what they want. Actually, they need this. Let me check what they want. They wanted to zoom in and use this. Yeah. But I will do this, which is in exercise 99, verify that the intermediate value theorem applies to the integrated interval and find the value of C guaranteed by the theorem. Guaranteed by the theorem. Okay, so let me do F1 101. I'll do 101 and 103. Yeah. I'll do 101 and 103. 101, what is the function? Your root x plus 7 minus 2, the interval 0 and 5, and I'm looking at f of c equal 1. Okay. At 0, it gives me square root of 7 minus 2. At 5, it gives me, look, if at 0 is what? Square root of 7 minus 2. This is square root of 4, so this is positive. F of 5 equal what? Square root of 12 minus 2, which is positive. So why he's talking about intermediate values here? This is not correct. What we did is not correct. Actually, he's looking for which equation? He's looking for this equation. F of c equal 1. So I'm looking for this. F of x equal 1. So I have square root x plus 7 minus 2 is equal to 1. This is the equation I'm trying to solve, which implies square root x plus 7 minus 3 equals 0. To do this intermediate value, we need to make it equal to 0. So my function, which I should work with, is this function, which is continuous in this interval. Now, g at 0 will be what? Square root of 7 minus 3. This is less than square root of 9, so this is negative. G at 5, it will be square root of 12 minus 3, which is positive. Now, there exists a root. We say, intermediate value theorem showed there is a root for g of x equals 0 or f of c equal 1, or f of c equal 1. Okay. They want us to find the root? Let me check. What do they want? And find the value of c. Yeah, you want me to find the value of c. So I need to find the root of this. So G at C will be square root of C plus 7 minus 3. I want it to be equal to 0. So square root of C plus 7 equal 3. Square it. C plus 7 equal 9. So C equal 2, which belongs to the interval 0 and 5, which is correct. Now 103, same idea. The function is what? X minus x cubed over x minus 4 between the interval 1 and 3, and I'm looking for f of c equals 3. This function is continuous in this interval, because I need to avoid this not equal to 4, which is not in this interval. So the continuity condition is satisfied for the intermediate parity here. But I'm working with what? I'm working with this equal 3. So my function, which I'm working with, minus 3 equals 0. Now G at 1 will be what? 1 minus 1, 0. It will be 0. So it will be minus 3, negative. G at 3, it will be x minus, not x, x is 3. 3 minus 27 over 3 minus 4 minus 3. Which is what? Minus 24 over, which is 24 minus 3, which is positive, I don't care. So intermediate value theorem guarantee there exists a root of g of x equals 0 in this interval, 1 to 3. A root in the open interval, 1 to 3. Okay. Now, if I want to find that root, what shall I do? I need to solve this equation. I need to solve g at c equals 0. So that implies c minus c cubed over c minus 4 minus 3 equals 0, or c minus c cubed over c minus 4 equals 3. So that implies c minus c cubed equals 3c minus 12. Take c cubed the other side and take c also the other side. So minus 2c minus 12 equals 0. No, this is plus 2c, sorry. Take the minus, this is plus 2c minus 12 equals 0. Now I can solve this. If you notice, c equal to is a root. Very clear root. So that will be factored as c minus 2 times something, times q of x equals 0. So I need to find this q of x through the long division, c cubed plus 2c minus 12. If you know, we do something like that in the prepare. So this is c minus 2. To be sure, there is no other roots. I need a space. Actually, this is enough. That means 2 is a root, which is what we're looking for. But for completeness, we don't need it. But c square multiply c cubed minus 2c square. Change sign. So 2c square plus 2c minus 12. Divide again. Plus 2c, which is 2c square minus 4c plus minus, this is plus 6c minus 12 plus 2. So it will be plus 6, not 2. Plus 6, it will be 6c minus 12, which is 0. So it's a root. So this function, actually it is c minus 2, c square plus 2c plus 6. This is impossible to be 0. Very clear. It will be c squared plus 2c plus 1 plus 5, which is c plus 1 squared plus 5, which is impossible to be 0. So if this is making 0, so c equal 2. which is belongs to the interval 1 and 3. So it's a root. I think I'm done with most of these problems. Where is the problems? No, we're done with this. So we're done with this. What we have here, concept things. Okay. True or false? I'll go to true or false. Okay. If the limit f of x exists and f of c equal L, then the function is continuous, which is the condition of the continuity. Okay. This is, I'm putting it here. So f of c equal L, limit exists, they are equal. This is the good conditions of the continuity. So this is very clear, true. Then f of x equal g of x for all x not equal to c, and f of c not equal g of c. Then either f or g is not continuous. This is also true, because f of c not equal to g of c, f of x equal g of x. When he say f of c equal g of c for all x, g f of x not equal to c. I know that the limit is goes to c for f of x equal the limit of g of x as it goes to c. But he add that f of c not equal g of c. So if this is continuous, it should equal g of c. If this is continuous, it should equal f of c. But I say f of c not equal g of c. It means one of them should not be equal. F not equal g of c or g not equal g of c. So one of them should be not continuous, at least. And this is what he did also here. This means the limit is the same. If they exist, at least one of these limit does not equal the corresponding function value. Okay. I mean 111, the intermediate value theorem guarantees that f of a and f of b differ in sign when a condition has at least 1 0. He's saying the opposite. If I have 0, is that means f of a should differ in sign? No. And he gave you an example here. Cosine. Look at cosine. Between 0 and 2 pi. Okay. F of 0 have the same sign, but there are many zeros between them. So the opposite is not true of this intermediate value theorem. The limit of the greatest integer function as it approaches 0 from the left is -1. This is not true. The limit of what? Limit of the greatest integer function as it approaches 0 from the left. Yeah, from the left. Yeah, 1, 1, 2. Limit as it goes to 0 from the left of the greatest integer function. So I'm having minus point something, that will be -1. Yeah, for sure it's true. Sorry for that. A rational function can have infinitely many x values of which it's not continuous. This is tricky somehow, because polynomials, rational means what? Polynomial of a polynomial. And the polynomial have finite number of zeros. Polynomials of degree m, degree n, it has finite number of zeros. So it cannot be infinite. But in general, yes. But for rational function, no. Understand? This is because in the denominator, we have a polynomial. This is a rational function. Rational function means polynomial over polynomial. Okay, this function is continuous in this. Very clearly is wrong, since it's not defined that x equal 1 to start with. So this is false. I don't know if 1 is not defined. And the limit does not exist. فوق البيع على قوله. طيب. These are word problems where they have function. Okay, you can deal with. You can look at these ones. Yeah, 120. I'll do 120. He says what? For all spheres with radii in the interval 5 to 8, there is a 1 with a volume of this. What is this? Let me do it here. 120. He says what? If you have a sphere with the radii between 5 and 8, okay, use the intermediate variety. For all spheres in the interval 5 to 8, there is a 1 with a volume 1,500. 1,500. He said there is one. Calculation هيكون صعب. Okay, مو مشكلة. I want to see if there is another one which is easier. Okay, I will do this one. No problem. Where is it? Go up and down. Yeah. I need something where the volume of that sphere, volume at R, should reach 1,500. He said there is a value. Why is that? What is the volume of the sphere? It would be 4 pi over 3 R cubed. 4 over 3 by R cubed. So now, if you check V at 5, and we know this is, I'm using calculator to do it. V at 5 will be what? 4 times 3.14 times 125, which is 5 cubed, divided by 3, which is 523.3. V at 8 will be what? 4 times 3.14 times 8 times 64 divided by 3. It gave me 2,143. I know this function is continuous. Look at this. V at 5, this is 5, this is 8. V at 5 is 500 something. And V at 8 is 2,000 something. Now, this is 1,500. Since the function is continuous, this is intermediate value. It means there is a value between 5 and 8 where I reach 1,500. That's the meaning of it. Okay. Trying to collect some problems. Yeah. I will do 127 and then 129 and then 131. Okay. Let me do 127. It says what 127? 127, it says this is to find all values of C to make this function continuous everywhere. Okay. So this is the function, which is 1 minus x squared, if x less than or equal to C, x in the x greater than C. So this function is continuous if the limit goes to C from right. This is continuous. So I care about the C only. The junction point should be equal limit goes to C from left equal f of C. This is what I need. C from right, I'm here, it will be C. C from left, 1 minus C squared. F of C is 1 minus C squared, will make no difference. So just I need this. Just I need to solve this equation, which is C squared. Yeah. Which is C squared plus c minus 1 equals 0. Which is, why he put it like this? 1 minus c squared is equal to c. 1 minus c squared is equal to c, so c squared plus c minus 1 equal to 0. I don't know how to solve it. Solve it by the formula. It will be minus b plus or minus square root b squared, 1 minus 4 ac. So 1 plus 4 over 2. So c should be what? Minus 1 plus the square root of 5 over 2, or c equal minus 1 minus square root 5 over 2. Who cares? These are numbers. Okay. 129 is saying what? The function, this function is not continuous because it's not defined as 0. So he says, what's the domain of f? All real numbers except 0. Very clear. How you can define f at x equals 0, which is not in the domain, in order for f to be continuous there. Okay, let me explain it now. 129, see if I have a space. F of x equal, what is it? Square root x plus c squared minus c over x. Very clear, is not defined. Where c is positive, he put c is positive, I'll put myself, okay? Where c is positive, he put c is positive, okay? C is positive. I'm sure x not equal to 0. It's not in the domain. So f is not continuous at x equal. Now I want to force it to be continuous. I want to redefine the function at 0 to make it continuous. So I need to check what will be the limit as this goes to 0 of this function. If you substitute, you have what? Because of that c is positive, so you have c minus c. That will be absolute value of c, which is c, 0 over 0. So I need to rationalize it. That will give me what? Limit goes to 0. X plus c squared minus c squared over x square root x plus c squared plus c. Oops. That will be cancelled, and then also x cancelled with x. That gives me what? 1 over, this is 1 over 2c. So if I define, now I define f of x, make it g of x, as what? As this function, if x not equal to 0, where c is positive, in all cases. And I'll make it at x equals 0, this value, where I know the limit of this is equal to 1 over 2c. So in this case, the limit is goes to 0, which I will resubstitute it here, will be 1 over 2c, which is f at 0, g at 0. So g is continuous everywhere. So I redefine f by adding only 1 point to make it continuous. Since this continuity, the limit exists, since I have removable discontinuity. And this is the meaning of removable discontinuity. I can't remove the discontinuity by a simple definition. I will do 131, discuss the continuity of the function, this function, which was in one of the exams. 131. This is the function. I know from this, h is discontinuous if x is an integer. And if you check that number, we discuss it, we say yes, if x is an integer, but we need to be careful. I need to multiply it by a number. It means the limit as this goes to n from right is not equal the limit as goes to n from left for the greatest integer function. However, when you multiply it by x, if that x is 0, it will kill these things, because 0 times a number, it will be a 0. So it means I have What I mean, what is goes to n from right, if I have x, guess 0 of x, x guess, this is different than this, but if you multiply by 0, I have 0 equals 0. So this is true, not h. I say great integer function. But for h, is discontinuous not only if x is not integer, a non-zero integer. Because if it is 0, it will be continuous. It will be 0 equals 0, and it's equal to f at 0. So this will be the condition. Okay. These are the true false I did. There are some review exercises. I did not notice something different. I think you can do all. They are the same. Check them. Now we'll go to this problem solving, where they have some problems. I think these are word problems. We have some problems here. We'll do them, which is number 6. Let me do them here. It says what? Number 6, this is find the values of a and b so that this limit exists and it's equal to square root of 3. I think also I bring it in the quiz. Something similar. X goes to 0, a plus bx. Find a and b. As we agreed, this is the denominator is 0. So for sure, the limit in the numerator should be 0. That implies what? Square root of a minus square root of 3 equals 0. So very clear, a equals 3. Take it there. That means limit x goes to 0, square root 3 plus bx minus square root of 3 over x equals square root of 3. Let me rationalize it first. This is plus. That will be what? Limit x goes to 0. Get a space. That would be what? 3 plus bx minus 3 over x. That would be cancelled. Also, it's cancelled. That would be b. This is 0 over 2 square root of 3. And that equals square root of 3. So that means b equal 2 times 3, which is 6. So b equals 6 and a equals 3. That's it. I'll do also number, oops. I'll do also number 7, these problem solving things. Number 7, finding this limit. Not difficult, but it also is not easy. It needs some calculation. It's just the algebra thing. I am leaving some spaces. Okay. Where is the one I did, number 6? This is 131. Oh, I did it after it. Okay. So number 7, I need to do this limit. Limit x goes to 1, square root 3 plus x to the power 1 over 3 minus 2 over x minus 1. I need to do this. If we substitute, you have 0 over 0. That means you need to rationalize the first one. Limit x goes to 1. Let me write this 3 plus cube root of x minus 2 over x minus 1 multiplied by the same thing. What you will get? Instead, you will get what? 3 plus cube root of x minus 4 over x minus 1. 3 plus cube root of x and then the square root plus 2. which is what? Limit is equals to 1 cube root of x minus 1 over x minus 1 cube root 3 plus cube root of x plus 2. You can do it in two ways. Either you rationalize this, or you simplify this. How to rationalize the cubed? That's the problem. How to rationalize the cubed? You cannot multiply by, this is wrong, to multiply by cube root of x plus 1. It will not kill it. To kill it, you need the cube root, which is, you know that x cubed minus y cubed. To reach this, I need x minus y, x squared plus xy plus y squared. So if I have cube root minus 1, make this like x, and this is y, to make it cube root cubed minus 1 cubed. Now I can kill the cube root. I need to multiply it by this expression, cube root of x squared, which is the square of this, which is x to the power 2 over 3. Mine plus 1 times this plus cube root of x plus 1 square, which is 1. If you go back, let me take this limit here. Limit goes to 1. What was the numerator? Cube root of x minus 1 over x minus 1 times 3 plus cube root of x plus 2. So this is, I need to multiply it by this expression to make it x minus 1. Because if you notice, this is x minus 1. This is what I want, to kill it with this one. So multiply by this expression. Just need to know how to rationalize a cubic root. And that give me what? The numerator, this times this, this times this, it will be x minus 1. Plus, I'm getting it. The rest is just calculation. The idea, I need to learn how to rationalize a cubic root. This is cancelled. Substitute at x equal 1. It will be 1 over 3 plus 1, 4, and the square root 2 plus 2, which is 4. 1 plus 1 plus 1 times 3. So the answer is 1 over 2. That's number 7. And then I will do number 8 is not difficult. Find the values of a, so that function is continuous. I want to check when the function is continuous, which is not difficult. Let me do it. Since I wrote it, I will do it. 8, let's do it in the next page. 8, this is the function. I want to find a. Very clear, I want to check the limit as it goes to 0 from right. Equal limit. I need the function. I need to be sure the function is continuous. Find a so that the function is continuous. But you need to be careful. This limit, ax over tan x, is what? This is a special limit. Huh? This one is special limit. Yeah. And this one, halas, the rest is the same. A squared minus 2. So this is a equal a squared minus 2. If at 0, it will not make a difference. Huh? No, it cannot be x. I don't think you can put the equality here. I think this is a mistake. You should put the equality here because the function cannot be continuous if the equality is here. It is not defined at 0. So I think he means the equality here. I think there is a mistake. Okay, I'll consider the equality here. It cannot be there. Or the function cannot be continuous. It is not defined at 0. Okay, so I have a squared minus a minus 2 equals 0. So it means a minus 2 times a plus 1 equals 0. So you need a to be 2 and a equal minus 1. If a equal 2, a equal minus 1, I have what? Continuous function. You can check it. Then I will do, I need 9. No, not 9. 9 is what? Graphs, yeah. Match the graphs. And he gave you some information. Can tell you which one satisfying this. And the limit is goes to 2 is equal to 3. This is okay. It goes to 2 equal to 3. This is not okay. Khalas, out. This one is to go to equal to 3. Wrong. This is okay. If it's continuous at 2, this is the only one continuous at 2. This is not continuous, not continuous, not continuous. Limit is equal to 2 from left equal 3. Yeah, I need to check which one is satisfying, which is I think you can do. I will do 10. Absolute Grace integer functions, and then I will do 11, which is also Grace integer function. That's it. This is what I will do. The rest I will leave it for you to see. 10. This is the function. Grace integer 1 over x. Correct? Yeah. I want to check the limit as it goes to 0 from right of this function. You need to think of it. 0 from right, it means what? 0.0001. So I'm talking about, yeah, think of x 0.01, which is 001, which is 1 over 100. What will happen here? Limit as goes to 0. Let me do at 1. At 1, I think is good one. At 1, left and right. For this one. Sometimes you cannot do it for everything. 1 from right, it means this one is greater than 1. 1 over a value, this than greater than 1. I can نتكلم على 1 over 1 point something. So this will be a value between 0 and 1. So this great integer will be 0. 1 from left, you're talking about 1 over 0.99999 something. So this will be more than 1. So this will be 1. I'll do 11. F of x equal gain integer of x plus gain integer of minus x. Do it at x equal 1. You want to do it at x equal half, for example. X goes to half, then I will do 1. Half, if we substitute, we agreed if you substitute is an integer for a linear function, that's correct. You can only substitute. So half, it will be 0. Half here, it will be minus 1. So that is minus 1. Now, the last one, which is as x goes to 1. You cannot do it. This does not exist. This does not exist. So you need to do it from right and left. And I think we did it many times. So that will be what? 1. And this is minus 1, so it's minus 2, minus 1. What is about from left? That gives me what? 0 minus 1, which is minus 1. That means the limit as it goes to 1 of this function will be what? Minus 1. So the limit exists. I think that's enough for 2.4. I did 2.4 and also I did the problem solving since we are doing 2.4 at the last yeah, that been the last section in chapter 2. That's all, I think. Thank you.